Hey guys, it's Michaela, and today I'm going to teach you how to calculate a one-sample Z interval. The problem is, a bottling machine is operating with a standard deviation of 0.12 ounce. Suppose that in an SRS of 36 bottles, the machine inserted an average of 16.1 ounces into each bottle. Create a 95% confidence interval. So the first thing you have to notice is that we are given the population standard deviation here, and it's given to be 0.12. And this is important because this means that it is appropriate to use a Z interval. We only use a T interval when we are given the standard deviation of the sample and we are using that to estimate the standard deviation of the population. But since it is so rare that we will actually be given the population standard deviation, we usually use T intervals, but for this case, we're just going to teach you how to calculate one sample Z interval. So the first step into calculating the Z interval is we have to check conditions. So there are three conditions that we have to check: random, normal, and independent. So for random, we are given that we have an SRS, so we can say that yes, it is random, and it's given. For normal, we have an SRS of 36 bottles, and that is already greater than 30, so we can say that 36 is greater than equal to 30, and this is normal because of the central limit theorem, or CLT, if you want to be lazy. So for independence, we usually put this in context by saying that the total amount of bottles is assumed to be greater than or equal to 360. 60 like that. And this is 10 times the sample size because we need to make sure that our sample is 10% of the population size. So all our conditions are checked, and let's move on to calculations.